So, first problem. We're given a problem that has a cube root and a power at the same time. All right, a cube root and a power at the same time. Now, one way to solve these problems, guys, always, is to convert into rational form. You could always do this. Like that. Okay, and then you can actually just type that in your calculator if you want to do it this way. I'm telling you now you can do that, but be careful, please. Because if it's, a problem like this, if you don't put your parentheses, it's going to screw it up. If you don't put parentheses around the 2/3, it's going to mess it up. So if you're using a calculator, this is your command. If you don't put that in exactly as you see it on the board right now, it will not come out to the right answer. A lot of people forget the parentheses around the 2/3, and that's one of these other choices here. I'll tell you right now it is. And the other easier way to do it simply is to say, what's the cube root of negative 27? Negative 3, isn't it? And then aren't you squaring that still? So what is it? Again, how do I get this negative 3? Somebody explain quickly in words to get the negative 3. Derek. Let's use our terms. Come on, we talked about this.
3 cubed. 27.
Yes. So again, we think of 3 values that are the same. When multiplied, they give us 27. That's just 3, because 3 times 3 is 9, times 3 is 27. But we have a negative. And when we have a negative and it's an odd index, we just make a negative. If it had been a negative and an even index, it's imaginary. Okay, so when it's negative and you have an odd index, you just take the same number but make it negative. Now, if you go ahead and type this in your calculator, some of you have been doing this, and you get -9 out of it. It means you're forgetting the parentheses again. Again, when you evaluate this, you should definitely be doing that in your head by now. Do not type that in a calculator. -3 times -3 is just 9. But if you were to do that, don't forget your parentheses there. Okay, number 2. Number 2, what are we doing here pretty much? Good, distributing, combine like terms, multiplying through. So quickly, let's do this. We got, distribute the -2 first. We get x to the positive 4. We get y to the -6 times 2 to the 3rd, x to the 3rd, y to the 9th, z to the 3rd. Again, do I need a times symbol in the middle there?
No.
No, I don't. We know that it's times here, okay? Now combine stuff. X will be how many? 2 to the 3rd will be 8. Very good. So start with that. So this number's done. How come? Let's just say we add the exponents there. Again, taking these two and combining those two that I crossed out, you get x to the 7th, because when you multiply with the same base, you add the exponents. Okay? What about the y's, guys? Y cubed here. How come cubed? Yeah, be careful here. See this -6? You could just do -6 plus 9 and get y cubed. The other way that some people do it is you take the -6, move it down to the bottom, right? And you get rid of it up here. But still, what do you end up getting? What's 9 and 6? What do they cancel to give you? Just the 3. Okay, so either way you can do it this time. You can move it down to the bottom and then cancel. And then the z just carries. Okay? Alright? All the other choices are common mistakes, just for a heads up. So if you move one thing instead of the other, those are the other choices there. Same as they've always been. Next one. Which of the following functions represents the graph below? Where does this graph start? What is the coordinate here? Thank you, Luis. I heard -1, 0, I heard 1, 0. It's 0, -1. So this tells me already that there's no horizontal shift, right? Well, what kind of shift do I have? A vertical, and where did it go? Then down 1. So I know that there's going to be a downshift. So right now I have this choice, and I have this choice, because I see the -1 on the outside. When I see a number on the inside, it's a horizontal shift. And this is horizontal. There is none. There is none. That's a choice, but +1 would mean the graph would be up here, and it would look like that. That's what +1 would be. So that one's out also. Now, the other way to do this problem, always, is to just take the points that you see here. See those data points? Plug them in and see which ones they work in. So start by plugging in the 0 here. This is going to be 0 for x and -1. When you plug in a 0 up here, you get +1. That's not right. Plug in a 0 here. Don't you get an imaginary part? That doesn't make sense. Here I plug in a 0, I get -1. That works. Here when I plug in a 0, I still get -1. That also works. So these are both choices right now. If I plug in a 0 here, I get 2. That's not -1. So you can always test your data points. Next. It's one of those next two. How do I know which one it is next? The A value. Good, the A value. So?
It goes from 1 to 1, and then the y value changes by 2.
Well done. Good. Way to point that out. Take a look here, guys. If this were your data points, you would have, for your XY table, you would have 0, -1. The next point would be 1, 1. The next point would be 4, 3. What are your Y values going up by? They're going up by 2 every time. 2 there, 2 there. So that means the A value is going to be 2. That's another way to look at that. Or you just simply take the point 1, 1 and plug it in. Plug in 1 here. You get 1 minus 1, which is what? 0, but we said it's 1, 1. Plug in a 1 here. You get 2 minus 1, which is 1. So you can always test your data points in every function, but it takes more time. So our answer choice is choice D. It is choice D. Now, the long way to do this would be to plot all of these in your calculator and see which one matches up with that. I would recommend not doing that because you're going to run out of time.
We're gonna run out of time on this test?
No, in general, this is all SAT prep stuff, Chase. So I'm saying in general, save time. Don't plug them all in your calculator. All right, next one. Try this on your own. I'll give you a minute and a half. Again, 1.5 minutes. That's all it should take you for this one. Whatever you want to make up, yeah, that's fine. That's I'll take a look though, and then I'll get back to you. You're going to come in after school? Okay. Anybody else have a homework for me in case they're going to make up some stuff today? When's the test? Test is Tuesday, guys, so the last day to make up for 48, 49, 50, 51 is Tuesday. But again, homework needs to be turned in before that. Yeah. Yes, yeah, absolutely. So you can start by writing this as 9x squared, this first part here, because it's going to be 3 squared times x squared. And 3 squared is really 9. What 3? This 3 right here? That's next to the x. I don't see a parenthesis around it. See the difference? Look at the difference there. Parentheses indicates I distribute to both things in there. No parentheses indicates that the 3 is only pertaining to the x. So at this point in time, 9 over 36. Good. So just put a 4 on the bottom. We'll have something left up top probably. Now, please take your positives and negatives and move them. These 6 all move up top. So put a +6 right here next to the 4 to make it easier for you. 9 over 36. Come on, keep up please. 1 over 4. Now, here you see there's a -5 right here. You're going to move it down below as what? When we see a -5 here, move it down as a positive. So just simply put a +5 there for yourself. And now you're pretty much done. What's going to happen here? What's left between the x's? Yeah, but 2 minus 3 is -1. But if I want all positive x, because it's going to probably be multiple choice, so just to keep that in mind. To keep it all positive here, I just want to think about there's 3 down below, 2 up top, leaving 1 down below. And as Louis said, it's x to the -1, which is really down below. Now, Now here I get y to the 10 up top, and the bottom I get z to the 14. Okay, again, if you had nothing up top, let's say all the variables have been down below, what's really up top? 1. A 1. Okay, again, there's a 1 up top really. Number 5. All right, quickly. Ash, go.
Wait, so like with the number, when it is a positive, adding up and that, like for example, y, that is going to be top, not the bottom. Because
The negative that was on the bottom moved up top, and now they're both up top and they're both positive, so they stay up top. Okay? Here, cube root. Cube root means I want to break these up, remember? What do I break them up into? Multiples of 3. So I'm going to make 2 of these like this. Now, the 27 can go over here, because the cube root of 27 is easy to take. What about the x to the 5th? How many of them should go here?
3.
And how many left over here, Juliet? So again, I start by breaking up my exponent into a multiple of 3 that is as large as it can be. So 3x to the 3rd here, x to the 3rd is the largest one. X to the 6th would be the next, but that's above that. What about y to the 6th? You leave it alone, right? You just leave it over here, because we can do this with the 3 there. The z, can I take the cube root of z?
No.
So I put it over here. What about the w? W2 over here, and how many go over here? 6 of them go over here. So again, please notice, whatever your index is these are all multiples of that value. So these 3 values can all be divided by 3. That's the key here. These values cannot be divided by 3. So now I take the cube root of 27, which is 3. I do 3 divided by 3, I get x to the 1. 6 divided by 3. 6 divided by 3. And then I just put the next part in here. Okay? Again, so when you're quizzed today, remember I said leave it in radical form? That's what that means. This is radical form. This is the first part here, this entire portion, and then this is the radical form part. Okay, this obviously can't be written in radical form. These are all whole number integers, or whole number exponents. 2 minutes, we're doing well. All right, now we got a negative value here. Okay, now we got a negative a value. First, you can always do this by translations, guys. If you want to use translations, that's fine. That's completely fine with me. Now, if I want to pick my first perfect square, I start by listing my perfect squares. Question becomes, how do I get 0 under the radical? What does x have to be?
0.
Negative 1. Because negative 1 plus 1 is what gives me 0.
Oh, you gotta make y 0?
I gotta make this quantity, the radicand, 0. How do I make the radicand 1?
0.
If x is what? 0. Try it. Just plug a 0 in for x, and don't you get a 1 there? How do I make this radicand 4? What does x have to be? 3. Because 3 plus 1 is what gives me that 4. How do I get a 9? What number does this have to be? Because 8 plus 1 is 9. How do I get a 16? So if you pick up on the pattern, it's just 1 less, right? Hence x plus 1. That's where that comes from. 1 less is the horizontal shift to the left. So this is really 24. Now you got to figure out the y values. And this is where it gets a little bit tricky. If you figure out the first y value, you could technically just reduce it by the a value every time, right? So here, if I plug in a negative 1, you get negative 1 plus 1 is 0. 0 times 3 is 0 plus 2 is 2. And what can I write for all the rest now that I know that? Just keep subtracting 3. What's next? Next. You could just keep going down by whatever the a value is because it's negative there. Okay? So your graph for this one, just as a quick sketch, is going to be at negative 1 up 2. It's going to be here, and it's going to look something like this. Okay, just to give you a quick idea. Study your practice questions. Make sure you're ready with all your homeworks if you're going to make stuff up on Tuesday. I want the homeworks during first period, not after school. Juliet came here with homework, so she can make it up after school today if she wants to. Are we clear on that? Again, make-ups. Any late portfolios? Pencils, people, pencils. I got a lot of stuff here. Yes.
Yeah.